Hey everyone, so before we begin with our video, we would like to make a small request. Kindly subscribe to our channel and like the video if it helps you, and also share it with your friends who may benefit from the same. Hey, so in this video, I'll be showing how to simulate a full bridge rectifier. So we'll be taking the load as an equivalent model of a motor, and we'll need a power GUI block to begin with. And with this, we'll need an AC voltage source. So rectifier essentially converts AC to DC, and so it's a single phase full bridge rectifier. So we'll need thyristors. We'll need 4 of them, 2 on each branch. So let's rotate it. So the same pulse has to be given to the anti-parallel thyristors, so the ones which are diagonal to each other. And for this we'll need a pulse generator. So we'll name this 1 and 3. So it'll go to the first and third thyristor. And the other one 2 and 4. So since we're taking 50 Hertz, the time period in seconds will have to be 0.02 seconds, and the phase delay will give a 30-degree phase delay, whereas it will be the same for the other pulse, but it will be, the phase delay will be 30 plus 180 degrees, so it will be 210. So it will be 0.02 into 210 by 360. Now we'll need a go-to block just to make the simulation model look neat. Otherwise you'll have too many wires going across each other and it can get messy. So as I mentioned before, we'll have to connect it to diagonal thyristors. And now we'll need an RLC branch, a series RLC branch, which we will convert it into a RL branch. So if there are 2 ways you can take a series RLC branch, or you could take a series RLC load. Both of them essentially do the same thing, but you'll have to take care of, but the representation is different. One of them will be in ohms and Henry and farad, but the other one will be in watts. So let's just set the voltages. The input voltage will be 220 volts AC, and the DC offset voltage will give it as 100 volts. So we'll need a voltage measurement block to measure voltages across the elements, and we'll need a scope to view these elements, view the voltage readings. So let's name what each of the measured values are. We'll also need a current measurement block to measure the current in the circuit. Make it into an RL block, and the value of resistance and inductance will just leave it as it is. So now let's run the simulation. So let's zoom in to see what it actually is. So that's kind of a legend. So as you guys can see, the current is in discontinuous mode because for a prolonged period of time it's in contact with the x-axis, and the the blue waveform is the input voltage, is AC, and the red waveform is a DC voltage. So, and the other one is a back EMF of the equivalent motor of the motor. So now we'll make it into a half bridge rectifier. So for this we'll need two diodes instead of thyristors. That's about it. So we'll just replace the two diodes with two thyristors with a diode and turn it and rotate it and place it. And we'll remove the unnecessary connections so that no one gets confused. Let's run the simulation. So this is the realized output waveforms, and if you guys do want to make it into continuous mode, you could try toggling with the inductance values, and you would probably see a change in the current output. It wouldn't be touching the 0 ampere line. It would be higher at all times. So hopefully you guys found this video useful. Kindly do check out our other videos, and if you liked it, like the video and subscribe to our channel. Thank you.